Welcome to the channel Professor Davinci. Tree representation. What is the tree data structure? Tree is a non-linear data structure. Let me draw the tree. Suppose this is the A, B, C, D, E, F. Okay. Last video we have discussed a lot about the tree data structure and its terminologies. There are around 13 14 important terminologies we use while working with the tree. For example, node, sibling, child, height, intermediate node, leaf node, depth, many things we have seen last video. So if you are not familiar with the tree data structure, please watch my previous video. Good. Now, so tree is a non-linear data structure, right? So how to represent a tree? We can represent a tree in three different approaches. One is array representation, array. Second is linked list, and the third one is left child and a right sibling. So these are three ways to represent a tree. Now let's go with the first one, array representation. Okay, so in array representation, three things you need to keep in mind. The first one is it is static. What is static? The array is static because suppose if I want to declare an array, so int a equals say around say 7. Okay, so I declare the array of 7, meaning the size is already declared. So during the runtime or during the course of while running, we cannot able to change the size of the array. So once the declared array size is declared, it is fixed. During the runtime, we cannot change the size of the array. Okay, now that's why it is static. Number B, second point, nodes are represented level by level. So nodes are represented level by, what is the level by level? So this is the first level, second level, and this would be third level. So level by level, nodes are represented level by level from top to bottom. Now the third point is the root node. The root node always at the 0th index. Root node is always at 0th index, and the position of left child equals 2 into n plus 1, whereas n is the index of the parent. Index of the parent, and the position of right child equals 2 into n plus 2, same thing, where n is the index of the parent. Okay, now so once we know the position, all those things, we need to store the array, store the trees. So before storing, we need to find the maximum size of the array for declaration. So for that, to store the tree of height h, we need the size, we need the size, say for example I can say equal to 2 power h minus 1. So I write clearly, oh it's gone, 2 power h minus 1. Okay, so for example if we need to store the tree of height 3, then what will be the maximum size of the array? Then the size of the array is two power 3 minus 1. 2 power 3 is 8 minus 1, 7. So you need to declare the size of 7. Okay, clear guys? Now let us take this small example. I can take this small example. So let me copy this one, copy, I paste it here. Paste. Okay, now let me array representation. So I have a tree, say this is the tree 1. I need to save this tree 1. I need to represent this tree in an array. So first of all we need to find the height. What's the height of this? Step 1, find the height. Find the height. What is the height of this tree? The height of this tree is 3. How 3? So this is our first height, second height, third height, say level. Okay, so this 3. So what is the size of the array we need? We need the size of the array 2 power h minus 1, which equals 2 power 3 minus 1 equals 7. So we need maximum size of array is 7. So I just so what is the size of the array? 7. So I open an array of 7 memory spaces. 1, 2, 3, 4, 5, 6 and 7. Okay, so there is 0 index, first index, second index, third index, fourth index, fifth index, sixth index. So total index from 0 to 6, total 7 spaces are there. Now I told you already that the root always, oh god, the root always is the 0th index, right? So here what is the root here? A is the root, A is the root, right? So A always takes the 0th position. Now where will be the B? So we need to find the position of B. So position of B, position of B. What is the position of B? B is the left child, right? Left child of A. What is the formula for left child? 2n plus 1. So B will be in the position 2n plus 1. What is the n here? N is the position, n is the index of the parent. What is the index of the parent? Parent is A, index is 0. So 2 into 0 plus 1 equals 1. So B will be in the index 1. Then position of B. Position of B is finished. Now the position of C. Now the position of C. Position of C would be, C is the right child. What is the formula for right child? 2n plus 2 right child, right? So position of C will be 2n plus 2, which equals 2 into, what is the, who is the parent of C? The A is a parent, but the index is 0. 2 into 0 plus 1 equals, sorry, 0 plus 2, right? Yeah, this is a, C is a right child, so it is 2. So C will occupy the place, position, second position. Similarly, position of D. Who is the parent for D? B is the parent for D. So what is the index of B? Is 1. So D position will be, D is a left child, so plus 1, which equals 2 into, the index is 1 plus 1, so it is 3. So D occupies the third index. Similarly, position of E. E is the right child, so right child of B. So 2 plus 2, what is the B index? 2 into 1 plus 2 equals 4. So this E will occupy the index 4. Now position of F. So F is the left child, right child of C, right? So 2 into n plus 2. Who is the father, parent of F? C, that is index 2. So 2 into 2 plus 2 equals 6. So F take the position 6. Oh, who will be in 5? 5 will be null, because if you look into the tree, C does not have the left child. C has only the right child, so left child is not available for C. So in array representation also left child will not be present, but we will reserve the seat for left child of C. So now seat has been reserved, and the value of the reserved index, that is 5, is null, 5, null value. Clear? So in this case, in future, if the C gets the left child, then it will be populated there in the index 5. Where it is populated? Here, index 5 it will be populated. Now currently C have no child, so it is nothing, 5, null is represented. Clear? So this is how we represent the tree data structure in an array. Clear, guys? So here the 3 things you need to remember. That first one, always the root node takes the position 0th index, on left child position 2n plus 1, right side position 2n plus 1. Before computing this one, we need to find the maximum size of the array. So maximum size of the formula is 2h, 2 power h minus 1. Clear? Very simple. Next video, I will be continuing with this one, linked list and left and right child sibling. We will see in the next video. See you guys. Have a great day.